Chapter A is called hypothesis testing. And the idea of hypothesis testing is that somebody has a claim, and pretty much your job is to disprove the claim or try to prove the claim. So in 8.1, we're going to talk about claims about mu. So this is how it's going to look up. The only thing that is new pretty much here is going to be step 1. HO is the claim. And then you're going to have one of these 3 alternatives. If you pick any of these 2, this is called a one-tail test. And one tail literally means you only have one tail on the table. And if this is the case, you're going to use our friend alpha from chapter 7. And when it's 2 tails, the last case is 2 tails. And here we're going to do alpha over 2. Which, if you remember in chapter 7, alpha was always what? Divided by 2. So that means confidence intervals are all what? 2 tails. So technically, if you want to think about it, this is the part that is new for now. Step 2, you did that in chapter 6. If you look closely to C star, this is the same formula from where? From section 6.3. This is the formula from the central limit theorem. The only difference is what I put a star on it there, and you'll see why. So therefore, this is not new. This is from section 6.3. Now the rejection region and the p-value is also not new. This comes exactly from section 6.1, and this is what I mean. Depending on which alternative you have, this is going to decide the whole problem. So for example, if you have this alternative, then the rejection region, which I'm going to call RR from now on, is going to be Z of alpha, which remember we saw those values in chapter 6 and in chapter 7. That was the one that was what, 1.96, 2.5a, and so forth. Okay, they will be the same values. If this is the case, then this will be minus Z of alpha. So this is our right tail, and this will be a left tail, which is one tail only. And then if this is the case, you're going to have plus or minus Z of alpha over 2, when this will be both of them. Okay? Then that's the rejection region. The p-value method, which I'm going to denote it by this, if you have this case, the p-value is going to be the probability that Z is greater than Z star. This will be the probability that Z is less than Z star. And when it's 2 tails, this will be the twice the probability that Z is greater than the absolute value of Z star. Now, if you look closely, this is exactly the stuff you did in 6.1, and this is always the green area. Remember, we had to find the green area. How do we find the green area? Before it was the yellow area minus 1. So therefore, this is not new. Okay. Now for the conclusion on the summary, there is only 2 things that could happen. Conclusion or summary, there is only 2 things that had to happen all the time. The first choice is you reject HO, the first choice. And the second one is fail to reject HO. Okay? All right, so now look to these 2 stars right here, and this will make sense in a little bit. It says if you want to support a claim, so you state the claim, so it becomes HA. So let me tell you what that means. If you notice here, the 2 choices are what? Reject and fail to reject. It's not fail and accept. And the reason is this. Look, if we go to the top, this is what we're going to try to do. In the first case, if you reject this, then automatically the alternative is true. But if you fail to reject, it doesn't mean that this is true. It just means what? You don't have enough evidence to reject it. That's what it means. Okay, so that's why it's called fail to reject instead of reject. And this is somehow based in the American system of justice that people are what? Innocent until proven guilty. But if you cannot prove somebody is guilty, does that mean that the person is innocent? Not really. So that's pretty much what this is about. Okay. Now, if you want the opposite, then if you want to disprove a claim, so you state it so it becomes HO. So when you disprove the claim, if you reject HO, you reject this one, then HA automatically becomes true, which is what I just told you right now. So, is that okay? All right, so let's do an example. For step 1, to decide which way you're going to go, just think about this. When it's one tail, that means you are okay with one side, but you're not okay with the other side. For example, let's say that your mom tells you she's going to give you $20. If she gives you $40, are you going to complain? No, okay? But if she gives you 10, are you going to complain? Yes. So one tail means you're okay with one side, but you're not okay with the other side. That's pretty much what it means. And two tails means you are not okay with either side. It's either equal or not equal. Okay? All right, so here it says company ABC produces car batteries. The CEO claims, so here is the key, claims that the batteries last at least 5 years. So technically, the claim is that the average is at least 5 years. And pretty much it says greater or equals to 5, but HO should always be with the equal sign. Okay? Then they have a survey of 49 people, and that one has a mean of 4.3, which is what? Less than what the person is claiming. And also think about this. If you buy a battery where they promise you they will last 5 years, and the battery lasts 10 years, are you going to complain? Probably not, okay? All right, so then the standard deviation here, assuming that is known, is 1.3. By the way, this is how you know you have to do these questions. The question is always going to say, is there enough evidence? That's how you know you have to do a hypothesis test, okay? Alpha has to be given, and if alpha is not given, it's 0.05 by default. Yes?
How did you get 1.3?
Or 1.6. It should be 1.6. So this should be 1.6. Okay? All right, so then the alternative should be mu is less than 5. Why? Because 4.3 is less than what they are promising. Okay? All right, so this means this is going to be a left tail. Okay? All right, so for step 2, we need to find the test statistic, C star. This is called the test statistic, but from now on you can just call it C star. Whatever that has a star is going to be the test statistic. And remember, the formula was this: the square root of n x bar minus mu over sigma. So if we plug in the values, what do we get? This is the square root of 49, right? Times what? 4.3 minus 5 divided by 1.6. And how much is that? It is, negative 3.1. Okay. Again, this is something you had to do in chapter 6, so this is not really new. Okay, so this is the part that is also not new, but it's a different context. For the step 3, you always had to find the rejection region. And in our case, the rejection region is going to be minus z of alpha. And the reason why it's minus is because you want the left tail, and because this is pointing to the left side. That's why this is minus. If this was greater, it would be pointing to the right side, so it will be positive, okay? And these values are the same values from before. So therefore, this will be negative 0.05, which, remember from the values I gave you before, this is negative 1.64 or 65. All right, so then you have to graph the rejection region. So you have 0 here, negative 1.64 is here. So if you are here, then this is what we call the rejection region. And this one is fail to reject, or used to cut it short, fail to reject HO. So now, this is what you're going to do. How much is the value for C star? How much was the answer for step 2? Negative 3.1, right? Is that in the rejection area or the fail to reject? Rejection. So just take a wild guess. What do you think the conclusion should be if it is in the rejection area? Remember, there's only 2 choices. You either reject or fail to reject. So what do you think it will be? Reject. So therefore, the conclusion, step 4, is reject HO, which means the mu is less than 5. And remember, you have to explain what this means from now on. So the explanation is there isn't, or there is not enough evidence to support the CEO's claim that batteries last at least 5 years. The batteries last at least 5 years. And that's it. All right, any questions on this? So now let's do the p-value method. All right, so for the p-value method, which by the way means probability method, for this one, step 1 and step 2 are the same. So you don't even have to write step 1 and step 2 again. So for this, you can go straight to step 3. In step 3, the p-value is going to be the probability that Z is less than C star. And again, this is one of the questions that you are supposed to know from chapter 6. So this is the probability that Z is less than negative 3.1. And this is what we call the green area before. You can use the table or you can use the calculator. It's up to you. So negative 3.1 is here. So remember, this is the green area. That's going to be the p-value. That's what you want. But from the table, you will get the yellow area. How much is the value from the table? I think it's 0.99910 or something. 3 nines and then 0. All right, so then what will be the p-value? It will be 1 minus 0.9990, okay? Which is what, 0.0010, okay? Or if you use a calculator, this will be normal CDF, then minus 1000 to negative 3.1, and it should give you exactly the same answer. Okay? Okay, so now I'm gonna tell you now a decision rule, and you're gonna use this the whole the whole semester. This is on the formula sheet too. This is what you're going to do when it comes to the p-value. You're gonna compare the p-value with alpha. If the p-value is less than or equals to alpha, the conclusion is gonna be reject HO. And if the p-value is greater than alpha, this is gonna be fail to reject HO. So based on what we have right now, what's the value for the p-value? It's 0.0010. And what's the value for alpha? It was 0.05, right? So which one is bigger? Alpha. So if the p-value is less, according to the rule I just have on the side, what should be the conclusion? It will be reject HO. And you don't have to explain these things twice. That's it. All right? Any complaints on these, people? Yes?
How did you get negative 1,000 for the calculator?
Oh, that's the lower bound, because remember, this is going to minus infinity, but instead of minus infinity, you can just write minus 1,000.
Okay.
All right, anything else? I'm going to set this one just for you and try this one so you can get the idea of what's going on. So this is what it says. The claim here is that the average is 50 grams of sugar. And the alternative is going to be that mu is greater than 55. And the reason for that is that X bar, greater than 50, sorry. And the reason for that is that X bar is 55, which is more than what the company is claiming. Here, the standard deviation is 5, and alpha is 0.025. Okay, so step one is the hardest part, so I did that for you right now. So just try to do this. Remember that this will be a right tail. So that means the rejection region will be on the right side. Okay, so just try this for like 4 or 5 minutes and see what you get. All right, so let's see what we have here. So Z star is going to be the square root of what? 90 times what? 55 minus 50 divided by 5, which is what? 9.4, okay? Or 9.5. Then what do we do in step 3? Remember, step 3, you had to find the rejection region, right? Since this is greater, the rejection region is going to be where on the right side, and it's going to be positive. So then this will be what Z of alpha, which in this case is 0.025. And how much is that? We've seen this like 1,000 times right now. What is it? 1.96. So then draw the rejection region, which is mandatory to do. So you have 1.96. So if you are here, it will be rejected. And here is failed to reject HO. Okay, so now what's the value for C star? 9.4. Is that in the rejection region or the failed to reject? Well, clearly it's on the rejection region, right? I mean, like, really is there. So then what is the conclusion? Is reject HO, which means the mu is greater than 50. And then you have to do the explanation, which is what? There is not enough evidence to support the claim that the energy drinks have at most what? 50 grams of sugar. That's it. All right, any complaints on this? Try the p-value for 1 minute and see what you get. So let me just do this part for you. So remember, for the p-value method, step 1 and step 2 are the same. So you can start in step 3, where the p-value is also going to be the probability that Z is greater than C star, which in this case is the probability that Z is greater than 9.4. Okay, so you can use the table, you can use the calculator. So just try that for 1 minute. Okay, so let's check. If we use the table, you look to the Z table, what is the biggest value on the C table? The biggest value is at 3.59, okay? And notice that the value corresponding to that, which is what we call the yellow area, doesn't change on the last column. It's always what? 0.9998. So what do you think that means? That after 3.59, it doesn't matter, okay? So now what we want is this area. So how will we find that? This will be 1 minus what? 0.9998, which would be 0.0002. And that's what we call the p-value. Now, if you use the calculator, it's gonna give you the precise value, but it's gonna have so many zeros that it can be crazy. So if it goes over 3.59 or even 3.5, just use this value. Otherwise, you use the calculator, this will be a normal CDF, and this is a 9.4 1000. So did anybody did that? What did you get? Anybody did it? So you will get like something. What is the first value? 4 point something, or
2.77.
2.77 e to the negative 21st, right?
Yeah.
Which means you had 20 zeros first, 20 zeros first, and then the number 277. So that's why if it goes over 3.5, it's easier to use this value for the p-value. For the purpose of what we're doing, this is good enough. Because remember, what's the last thing you had to do with the p-value? You're going to compare the p-value with alpha. What was the value for alpha? 0.025. This is clearly less. So that means what? Reject HO. And that's it. Any questions on this? The difference between 8.1 and 8.2. Let's take a wild guess. Instead of using Z, we're going to use T. So the rejection region has to use the T table, and for the p-value, you also have to use the T table or the calculator. But the process is going to be exactly the same. Okay? Okay, so in section 8.2, the difference is now we're gonna use T instead of Z, and usually when we use T is because sigma is unknown, but equally importantly is that N is pretty much always less than or equals to 30 or less than 30. That's when we're gonna use T. But notice this is the same thing from before. This is one tail, which means you're going to use alpha. This is two tails, which is going to be alpha over 2. Again, these two formulas are exactly the same formula, just that this one is easier for computation because you only have to divide 1. And here's going to be the difference. The rejection region or the p-value is going to change from Z to T. So you have this case. It's going to be T of alpha. This one is going to be minus T of alpha. Remember that they require degrees of freedom. And this is going to be plus or minus T of alpha over 2. And the p-value is going to be very similar. So the p-value is going to be the probability that T is greater than T star. This one will be the probability that T is less than T star. And this twice the probability that T is greater than the absolute value of T star. So as you can see, it's the same thing. You're just replacing a Z for T. And the conclusion of the summary is exactly the same as before, which was what? What are the two choices? Reject HO or what? Or fail to reject HO. Okay? Let's try this question. So here it says the mayor of LA claims that the average salary is $20 an hour. So the mayor is claiming the mu or the average is 20. So that's a claim. So let's see what information we have. Here it says N is 25. X bar from the 25 people is 18, which is less than what the mayor is claiming, and the sample standard deviation is 5, and alpha is 0.05. All right, so what do you think it should be the alternative? Greater or less? Less than 20, right? Because the average from the sample was 18, which is less than what the mayor is claiming. All right, so for step 2, we need to find T star which again, remember, is that anything that has a star, it will be the test statistic. So this is what? The square root of, what is it? Of 25 times what? 18 minus 20 over 5, which is equals to negative 2. All right, any questions on this? Okay. All right, so the rejection region, this is a part that is new compared to 8.3, but new is not the best word to use, but new in quotation marks. So this is gonna be negative. Why is the rejection negative? The rejection region gonna be negative? Because the alternative is what? Is less, right? So since this is less, then that's telling you that you have to use a left tail. Okay. All right, so then the rejection region is gonna be minus T of alpha with whatever degrees of freedom we have. So in our case, this is negative T of 0.05. And how many degrees of freedom we have? Remember, the degrees of freedom is n minus 1. So what should be the degrees of freedom? 24. 25 minus 1, which is 24. Now, what is that value from the table? Look to your t-table. What is it? Negative 1 point what? I think it's 711, no? But just check. 711. All right, so now remember that the rejection region has to be in which side? The right or the left? The left. Why? Because it's negative, right? So you have 0. You have negative 1.711. So this part is the rejection region. And this is the fail to reject HO. All right, so same thing is T star in the rejection region or in the fail to reject. So T star is what? Negative 2. So therefore, what should be the conclusion again? So the conclusion is reject HO, which means that mu is less than 20. By the way, it doesn't mean that the questions are always rejected, okay? It just happens that examples with this so far are rejected. Now, what is the explanation here? Is that there is not enough evidence to support the claim that the average salary is what? Is $20 per hour. I mean, you can be more specific and you can say there is no evidence to show that the mayor's claim that city employees made $20 per hour is true. That's it. All right, so now the p-value gets, yes.
The 24, can you show me how you got that?
Yes, n is 25, right? N is 25.
Oh,
So the degrees of freedom is n minus 1, okay? All right, any other questions? No? All right, now the p-value is easier to do with a calculator than the table at the beginning, but if you become good with the table, you can do it equally fast. So I'm gonna show you both ways. So here it is. Let's do the calculator first. So remember, for the p-value method, just like the last section, step 1 and step 2 are the same. That's not gonna change. Now, for step 3, the p-value is going to be the probability that t is less than t star, which in our case is the probability that t is less than negative 2. Okay. So if you use the calculator, so take out the calculator, you need to go to second variables, just like the same way you did before for the normal. But instead of picking normal CDF, pick T CDF. And then the lower bound is going to be minus 1,000. And the upper bound is going to be -2. And the degrees of freedom was 24. How much is that? What is it? 0.0, then what? 28. All right, so that's the p-value. And now let's say that you don't have the calculator, or you run out of the battery right now, or whatever happened, okay? So how will you do this with the table? All right, with the table, you are not gonna find the exact value, but you don't need an exact value. All you need is an approximation. This is how you're gonna do it with the table. The value for T star, remember, is what? Negative 2, or the number 2, right? How many degrees of freedom we have? 24, okay? So just look to 24, which is this line right here. So if you were gonna pick the number 2, the number 2 is between which two values? Between what and what? 1 point between this one and this one, right? The number 2 will go there, okay? So then just go to the top and just pick something between 25 and 50. Literally anything between 25 and 50. So what's your favorite number between 25 and 50?
I'm lost as to how that 2 ended up there.
Oh, because that was a T star, right? T star is -2. Right. Since the table doesn't have negative values, you have to go with a positive 1. So the reason why we're looking for 2 is because of these 2 right here. Okay, because T star is 2. -2.
Oh,
okay.
I see. Okay.
So that's the one you're gonna look for. Then you go to the degrees of freedom, which we have how many? 24. And we're trying to find the 2, and 2 happens to be between those 2. So then the p-value is gonna be between these 2. And just pick anything between 0.25 and 0.50. And remember, that's not the exact value, but we don't care about the exact value. All you need is an approximation. So what is your best choice between those 2? Speak anything. 0.40. So you can say the p-value is the probability that t is less than -2. So this will be 0.40. Okay? So that's what you got from the table. And you have the choice to do the table or the calculator. It's up to you. Now, what is the last step we have to do? You're gonna compare what? The p-value, which I'm gonna put the 2 together here, 0.2a, and the other one was 0.40, right? One is the calculator and another one is the table. Alpha is how much? 0.0 what? What was it? 0.5? Yes. And doesn't matter which one you pick of the 2, both of them are what? Less than alpha, either the table or the what? The calculator. So 20a is less than 50, right? Because this has a 0 there, just to make sure. And also 40 is what? Less than 50. So this is the calculator, and this is the table. And the calculator is more precise, but you don't need a precise answer. So if the p-value is less than alpha, remember what does that mean? Reject HO. And that's it.
I have a question.
Yes?
On step 3, you said you can either do it with the calculator or the table.
Yes.
So when you do it with the calculator, you get the 0.028.
Yes.
And then on step 4, you got 0.40.
That's the calculator. So and the table. So they're not gonna give you the same value.
Right. So then in step 4, are you using both of those methods?
You can use either one of the 2. Say
Oh, I see. Okay.
20a is less than 50, and you decide 40 is also less than 50. So that's why I say it doesn't matter which one you pick, it's going to give you the same answer.
You just put both.
The value for n is what? 10, because you have 10 numbers. And here Pedro claims that cat owners in Long Beach spend on average of $8. So that's the claim. So step 1, the claim, or HO, is that mu is equals to 8. Okay? Now, if we use the formulas from chapter 3, you'll find that the average is 9.2, so I'll save you some time, and that the standard deviation is 3.2. Okay? Now, you notice here there is no alpha given, so what does that mean? What's the value for alpha? 0.05. If alpha is not given, it's 0.05. Okay? So then, based on the sample mean, what should be the alternative? Less or more than 8? More, so it should be more than 8, okay? All right, so use this information, do step 2, step 3, and so forth. So for the step 2, T star is going to be the square root of what? 10, because remember n is 10, times 9.2 minus 8 divided by 3.2. And how much is that? How much? 1.93? I think it's 1.2, no? Just check again. Yeah, it's 1.2.
I thought it was 1.9.
1.9?
Wait, isn't it divided by,
3.2, right?
but the formula has alpha on
No, it's sigma.
Which one?
This should be, the formula should be n x bar minus mu over s, so which is 3.2. So it should be 1.2.
Yeah, I'm looking at.
Okay? All right, so then what is the rejection region for step 3? So that should be the formula. So for step 3, the rejection region is going to be positive T of 0.05 with how many degrees of freedom? 9. How do we get 9? Because n is 10. And how much is that from the table? 1.8 what? 33. All right, so then the rejection region, remember, it has to be on the right side. You have 0, 1.833. So if it is here, it's rejected, and here is failed to reject. All right, so what will be the conclusion here? T star is 1.2, right?
I don't understand how you got 1.2.
So what is the conclusion is failed to reject, right? So they will be failed to reject HO. Now remember, if you fail to reject, it doesn't mean that this is true. All it means is you don't have evidence to reject it, okay? So what this means is there isn't or there is not enough evidence to reject Pedro's claim that the amount of food, that the amount you had to pay is $8 per hour and so forth. Okay? Okay, so now let's try the p-value. So for the p-value, let's do the two methods, the calculator and the table. So for the step 3, the p-value is going to be the probability that t is greater than t star, which is the probability that t is greater than 1.2. So you don't have to do a graph for the p-value, but it's better. So greater than 1.2 is this, which is pretty much the green area, like I told you before. All right, so if we use a calculator, this will be TCDF. The lower bound is 1.2. The upper bound is 1,000, and the degrees of freedom was 9. So how much is that from the calculator? What is it? 33? 303?
Yeah.
All right. Okay, so that's the precise value using the calculator. So for the step 4, what do? You compare the p-value with alpha, and the value for alpha was 0.05. So which one is bigger? Well, now the p-value. And based on the rule we have there, if the p-value is greater, remember what does that mean? Fail to reject HO. Okay? Now, let's say that you don't have the calculator, so how can you approximate it with the table? Okay, so if we use the table, what is the value that we're trying to find? 1 point what? 1.2. How many degrees of freedom we have? 9, right? 9 is here. So 1.2 will be where? Somewhere here. Whenever you end up with a number there, and you should write this on the table, you should always use 0.2. For any value that lands in here, you should always use 0.2. And if the value landed here for whatever reason, which it could happen, just use 0.001. And those are not the exact values, but they are enough for the purpose of what we're doing right now. So therefore, since 1.2 is here, then all you have to do is pick what? The p-value to be 0.2. So therefore, you can say, or for the p-value, then the p-value would be the probability that t is greater than 1.2. If we use the table, this is around 0.2. And then remember for step 2 again, 0.2 is clearly greater than alpha, which was 0.05. So the conclusion again is fail to reject HO, which is exactly the same thing. So you have two choices. It's up to you which one you want to use.
Can you scoot it over so I can see the number that?
In section 8.3, again, this is the claim. These two here are the one-tail alternatives. This is the two-tail alternatives. This is the official formula, but this one may be easier for computational purposes. So you can write it like this. Just don't forget the square root. And this is easier because you only have to divide 1. Now the rejection region and p-value, this is 100, not close to 100% the same as section 8.1, where remember we have z of alpha minus z of alpha and plus or minus z of alpha over 2. Like it's exactly the same. The same thing happens for the p-value. So the rejection region and the p-value in this section are exactly the same as 8.1. And the conclusion is the same as before. You only have two choices: reject or fail to reject HO. That's it. Okay, so just try that. Yes, that's right. Right. So as you can see, okay, let's look at this closely. All right, so any complaints on this, humans? No? All right. Okay, so before we go to the last one, let me make sure that you understand this. So just write this in a separate, this is not a test or anything like that. I just don't have any space to put it in there. So let me ask you one more, and then we'll do the last section. So let's say that this was a claim that P is 0.4, and the alternative is that P is greater than 0.4. So first of all, this is not two tails. Why? Because it doesn't have the not equal, okay? So then here, let's say that N is 200, and let's say that X is 90. So therefore P hat will be 90 over 200, which is what? 0.45. Okay? So on the test, you can have the question just like this. Okay, and the test, when it comes to these questions, which you have at least 2 of these on the test, and I'll tell you more like that, it could be like this or it could be a more problem. But if it is like this, then it should be no reason to not know what you have to do. Clearly, this is telling you what is the right size. So let's say that this is a question. So just try this for 5-6 minutes. All the information is already there. So just do this on the, you can do it on the back page or whatever, but this is for you know, you don't have to do it in. Well, I think I can write it here actually. Hold on. So what was the thing? H0 is P equals to this should be greater. And here N is 200 and X is 90. So from here, that means P hat is and you notice there is no alpha. If I didn't did I tell you what alpha is or no? So if alpha is not given, remember it's 0.05. Let's check. So for step 2, C star is going to be the square root of what? 200 times what? 0.45 minus 0.4 divided by the square root of what? 0.4 times 0.6. And how much is that? 6.45? 1.44, no? So this is 1.44. All right, so then step 3 of what do we need to find? The rejection region. Remember, this is not 2 tails, this is just 1 tail, so this should be a Z of what? 0.05, which is what? 1.64. So you don't have to divide it by 2. So then the rejection region is going to be only on the right side. So this is the rejection region, and this is the fail to reject. So now is 1.44 in the rejection region? No, right? It's close, but it's not there. So therefore C star is 1.44. So then step 4, what is the conclusion? It will be fail to reject HO. And then explain. What is the explanation here? There is not enough evidence to reject the claim that what? That the proportion is 40%. That's pretty much it. All right, any questions on this? Okay, so what about the p-value? So remember the p-value. Yes. Okay, so let's look to the p-value. So remember the p-value is going to be the probability that z is greater than 1.44. So this is just the what we've been calling all along the green area. So you have 1.44. You want this part. The table will give you this. What's the value from the table for 1.44? What is it? 0.9 what? 92. So then what will this be? The p-value will be 1 minus 0.9192, which will be 0.01. Okay? All right, so then what's the last thing you do? By the way, if you do the normal CDF with the calculator, this will be 1.44 1000. It should give you exactly the same answer. Okay, so what is the last step? For step 4, you compare the p-value with alpha, and the value for alpha was 0.05, right? So which one is bigger? Well, clearly the p-value. And remember, if the p-value is bigger, that means fail to reject HO. That's it. Right? Any complaints on these, people? So again, this is the claim. This is alpha. This is going to be alpha over 2. This is the test statistic. The rejection region is going to be either chi-square right, chi-square left, or both of them. And then for the p-value, if this is the case, it's going to be the probability that chi-square is greater than chi-square star. If this is the case, it's going to be the probability that chi-square is less chi-square star. And if it is both, it's going to be twice the probability that chi-square is greater than chi-square star. Sometimes, depending on the question, this actually could also be less, but don't worry about that for now. And the conclusion is the same as before, the same since 8.1. Okay. This for 2 minutes. Let me just do the step 1. You should be able to do the rest. So step 1 says Mr. Ratz claims that the standard deviation, so there is no confusion that this is about the standard deviation. See, the claim is that the standard deviation is exactly 60. So this is going to be 2 tails. So HO, the claim is that sigma is equals to 60. So the alternative is that sigma is not equals to 60 because it's 2 tails. Here, the sample standard deviation is 70, n is 20, and alpha is 0.01. So that's all the information you need. So do step 2, step 3. Remember, for step 3, you had to find chi-square right and chi-square left. Okay, so just try that, and we'll go over this in a couple minutes. Okay, so let's check. So for step 2, remember, chi-square star is going to be n minus 1 s squared over sigma squared, right? Which will give you what? 19 times what? 7 squared over 60 squared, which is how much? 25.9. That's pretty much right. All right, so then what do we find in step 3? Step 3, you need to find the rejection region, which in this case, since this is 2 tails, you need to find chi-square right, and you also need what chi-square left. Now remember, chi-square right is going to be chi-square of 0.005. Why? Because alpha has to be divided by 2, because it's 2 tails. And then the degrees of freedom is 19. And the left side is going to be 0.995 with 19. Remember that this value plus this one has to add to 1. Now, what are these values from the table? What is the first one? Just look to the chi-square table. 38.582. What about the next one? 6.844. All right, so then draw the rejection region. So you have 0, 6.844, and 38.582. So if it is here, it's rejected. And if it is here, it's also rejected. Let me put it in red instead. So this is the rejection region. So is this, and this is the fail to reject. All right, so then is chi-square star in the rejection region or not? No, right? So chi-square star is somewhere here, which is not in the rejection region. So therefore, what is the conclusion? It's a fail to reject HO, right? Which means what? There is not enough evidence to reject Mr. Rat's claim that sigma is equals to 60. That's it. All right. So, any questions on that, people? All right. What about the p-value? There is always a p-value. So for the p-value method, step 1 and step 2 are the same, so we can go to step 3. So the p-value is going to be twice the probability that chi-squared is greater than 25.9. And again, you can use the table to approximate this the same way we use the t-table, and I'll show you right now. But let's use the calculator first. So this will be 2 times chi-square CDF, 25.9, 1000, and then what are the degrees of freedom is 19, right? So how much is this? Use the calculator. 0.265. So what is it? 0.265? Yes. All right, so then what are we doing? Step 4, you compare the p-value with what? With alpha, which is alpha was 0.01, no? So clearly this is greater. So greater means what? That this is fail to reject HO. Okay. All right, so any questions on this? Yes?
In just step 3, I'm going to get it from people.
Yeah, I'm going to show you right now. Okay. All right, so now again, let's say that a calculator died or something happened. All right, so the table, if we use the table, this is what we get. How many degrees of freedom we have? How much was it? 19, right? So you look to 19. This is 19. What's the value we're trying to find? 16, no? No, 25.9, which is technically 26, right? So 25.9 will be here. So then we go back to this, and I told you just pick something between 0.1 and 0.9. Well, clearly 26 is closer to what? To 27. So you should pick something to close to what? 0.1. So you just pick 0.2. Whenever you're here in the middle for this one, you should always use 0.2. Okay? So then if we use the table, so from the table, the p-value is going to be 2 times 0.2. The reason for the 2 is why? Because it's 2 tails. Otherwise, just use a 0.2. And 0.2 times 2 is 0.4. Remember, this is not the exact value, but you don't need the exact value because you're just comparing that with alpha. And clearly, 0.4 is going to be greater than what? Than 0.001, right? So this is going to be greater than alpha, which was 0.01, and that still means fail to reject HO. So it's not going to change. Okay? So the two tables are actually read the same way. Okay? So just try this one. Let's say that HO is sigma is equals to 22. Let's say that the alternative is that sigma is not equals to 22. Here, let's say that n is 10. Let's say that S is 40, and let's say that alpha is 0.05. Okay, so actually let's do this one together. So this is a step 1. What should be step 2? Chi-square star is going to be what? 9 times what? 40 square divided by what? 22 square. So how much is that? 29.8. All right. Then on step 3, remember we need to find chi-square right and chi-square left for the projection region. So this is chi-square of 0.025 with 9 degrees of freedom. And this one is chi-square of 0.975 with 9 degrees of freedom. So how much is that from the table? So the first one is what? 19.023. What about the second one? 2.700. All right. Okay, so then draw the rejection region. You have 0, you have 2.700, 19.023, and again this and these are the rejection region. Okay, and this one is the fail to reject. Now, is chi-square star in the rejection region or not? Yes, this time it is, right? So chi-square star is 29.8. So then what is the conclusion? Reject HO, right? And then remember, when you reject the claim, automatically the alternative is true. So that means there is now evidence to show what? The standard deviation is 22. Okay. All right, and then finally, what about the p-value? This will be twice the probability that chi-square is greater than 29.8. So let's use the calculator. This will be 2 chi-square CDF, 29.8, 1000, and then 9 degrees of freedom. So how much is this? So this is for the p-value. Right, so what is it? 9.1? 9a? E to the what?
9.48.
9.48? E to the what? Negative 4?
Yeah.
Remember, this means 0.000948. That's what it means. Okay, you have to be careful with that. All right, so then step 4, what will be the last thing you do? You compare the p-value 94a with what? Alpha, which was 0.05. And clearly this is less. So less, it means what? Reject HO. Now you look to the table to give you the same answer. Okay, so for the table, how many degrees of freedom we have? It was 9, right? And what's the value we're trying to find? 21? 29. Well, 29 is where? Here. Just like for the T table, what did I tell you? You're in that extreme. What value should you pick? 0.001, right? So then it does the extreme and the thing disappear again. So then the p-value will be 2 times 0.001, which is what? 0.002. So remember, this is step 3. So for the step 4, you're gonna compare the p-value, which is 0.002, with alpha, which is 0.050. This is still less, and it still gives you the same conclusion. So not having the calculator should be no issue to get the answer equally fast. All right? Any complaints on this?